Welcome back to Math with ACE. We're focusing on statistics today. We are doing more conditional probability, more intersections, more unions, but this time with a two-way table or contingency table. We're going to be using some fractions here, and conditional probabilities are given to us, and we need to fill in the table. So Muddy Mouse lives in a cage with 3 doors, and if Muddy goes out the first door, the probability he gets caught by Alyssa the cat is 1/5, and the probability he's not caught is 4/5. Notice that you have 1/15 and 4/15. Well, that's interesting. What's happening here is the information that you're given in the problem is conditional. It's saying if Muddy is going out the first door, so given he's going out the first door, the probability he gets caught is 1/5. Probability not caught is 4/5. So it's not necessarily what we would put. The 1/15 and the 4/15 is the intersection. And the probabilities we're given in the problem are conditional probabilities. So they vary a little bit. In order to determine the door 1 total, I can add 1/15 plus 4/15 to get 5/15. The probability that Muddy's going to get caught going out the second door is 1/4 and not caught is 3/4. Again, those are conditional probabilities. The intersections are 1/12 and 3/12. And when we get to tree diagrams in our next video, you'll understand we could draw a picture of this and make it a lot more clear in terms of going out doors 1, 2, and 3, each of those being equally likely, and then getting caught versus not caught, and each of those probabilities. So the first door of getting caught, this one was 1/5. The second one of getting caught was 1/4, and the third one was 1/2. Not caught was 4/5, 3/4, and 1/2. And the tree so this tree diagram, when we go to our next video, you could see those are your conditional distributions, and the intersections are found by multiplying them. 1/3 times 1/5 is 1/15. So reference that video to come back and kind of see where these probabilities are. But if I add 1/12 plus 3/12, I get 4/12. And 1/6 plus 1/6 is 2/6. Now I need to add a cross, and these denominators are not in common denominator form. So what I would want to do is find the least common multiple that each of these numbers is goes into, okay? 15 is going to be the biggest one. 12 doesn't go into 15. If I double 15, 30, 12 doesn't go into 30. Again, multiply. 45 is the next multiple. 12 doesn't go into 45. 60, 12 does go into 60, and so does 6. So my denominator would be 60. So this is how many 60ths do I have here? Doing some fraction math here with common denominators. 15 goes into 60 4 times. So 4 times 15 is 60. 4 times 1 is 4. 15 times 4 is 60. 4 times 4 is 16. In terms of the next column, 12 goes into 65 times. So 12 times 5 is 60. 1 times 5 is 5. 12 times 5 is 60. 3 times 5 is 15. And then 6 goes into 60 10 times. So 6 times 10 is 60, and 1 times 10 is 10. 6 times 10 is 60, and 1 times 10 is 10. Now I can add across. I have 4 plus 5 is 9 plus 10 is 19, which means the rest needs to sum to 41. 16 plus 15 is 31, plus 10 is 41. So now I've completed the table. What is the probability that Alyssa does not catch Muddy? Well, we've calculated this in our table already. Muddy does not get caught 41 out of 60. What is the probability that Muddy chooses door 1 or door 2, given that Muddy is caught by Alyssa? Muddy is caught. All we care about the fact is Muddy is caught. So of the 19/60ths, how many of those were door 1 or door 2? Door 1 was 4/60ths. Door 2 was 5/60ths. That gives me 9/60ths over 19/60ths. I don't like fractions. 60 is not going to be a nice number to be divisible. So what I'm going to do is I'm going to not turn them into decimals, but I'm going to flip and multiply. So I have 9/60ths multiplying by the reciprocal 60/19ths. The 60s cancel, and I have 9 out of 19. So this was a big fraction problem involving finding common denominators, finding a least common multiple, determining intersections, adding fractions, and then doing a conditional probability. Let's do one more problem. Table 3.4.8, that's this one right here, 3.4.8, contains the number of crimes per 1,000 inhabitants in the United States over the span of several years. Okay. I want to fill in the table first, but then I want to find some probabilities. I'm doing and, which is intersections. I'm doing or, which is general addition rule, where I'm adding unions. I'm doing given probabilities. I need to find my totals. 145.7 plus 732.1 plus 29.7 plus 314.7 gives me 1,222.2. 133.1 plus 717.7 plus 29.1 plus 259.2 is 1139.1. 119.3 plus 701 plus 27.7 plus 239.1 is 1087.1. 113.1, 113.7 plus 702.2 plus 26.8 plus 229.6 is 1072.3. I can add all of those together to get my overall total. Now, the reason that these are decimals, even though we're talking about the number of crimes, is because it's per 100,000. So the total here is 4,520.7. Summing down the robberies, 145.7 plus 133.1 plus 119.3 plus 113.7. I get 511.8. 732.1 plus 717.7 plus 701 plus 702.2 is 2853. Now, I'm not going to want to make these, I don't want to leave these as fractions because I'm going to have decimals, which means it's a complex fraction or compound fraction. So I want to make sure that I turn those all into decimals. 290 or 29.7 plus 29.1 plus 27.7 plus 26.8 is 113.3. 314.7 plus 259.2 plus 239.1 plus 229.6 is 1042.6. And adding them all together just to make sure I did the math correctly, I do get the same answer. All right, what is the probability of being year 2 and robbery? So year 2 and robbery, and it's an intersection, not an or, so I want to know where they come together on the chart. That is 133.1 out of the total 4,520.7. And when I divide the numerator, 133.1 divided by 4520.7, I get 0.029 to 3 decimal places. Same approach for year 3 and burglary. The burglary is here. Year 3 is here, and it's an and. So they come together at 701 out of 4,520.7. Dividing in my calculator, 701 divided by 4520.7 gives me 0.155, or 155,000th if you want to use correct math terminology. Or year 3 or burglary. So remember, I add 28, or let's do year 3 first. Year 3 was 1,087.1 over 4,520.7, plus the burglaries, 2853 over 4,520.7, minus the intersection. It's hard to see there. It's 701, minus 701 over 4,520.7. I am going to add 1087.1 plus 2853, and then I'm going to subtract 701. That's going to give me 3,239.1, and then I divide that by my total to get a decimal, which gives me 0.717. All right, now I'm into conditionals. I want to find the probability of being year 4 given vandalism. I only care about the vandalism then. How many were vandalism for the violations? That was 113.3 out of, actually, I don't care how much it's out of because it's a condition. So of those 113.3, how many were year 4? 26.8. So dividing 26.8 by that 113.3, I get 0.237. And let's do a condition one more time. Being, what's the probability of it being a vehicle given it's in year 1? So I care about year 1. And then of those, 1,222.2. How many were vehicle? 314.7. Dividing that out, I get 0.257. All right, so we've encountered decimals in the two-way table now, fractions in the two-way table, and explored the different types of probabilities that we see. Our next set of videos is going to focus on tree diagrams and Venn diagrams. Thanks for watching.